It's chemistry demo day here at the Gravel house. This is
Duncan.
And I'm Mr. Gravel. Welcome back, guys. We have another chemistry demo for you today. We're going to be testing the reactivity of some of the some of the elements that we have in our periodic table. So a little introduction for you. Metals are quite diverse, but they have some traits in common. They are usually shiny, flexible, and good electrical conductors. And we know that from our electricity unit because we use copper in the wiring that we tested with our battery cells that we made up together in class with our series and parallel diagrams and circuits that we made prior to our March break. So they owe these properties to their peculiar structure. On a nanoscopic level, any metal is an array of charged metal particles, which are ions. We will learn a little bit more about those as we get through our chemistry unit. Inside a cloud of electrons, so we're going to talk about how each of those are arranged. Ions of some metals value the comfort of this cloud more than others. They can push less lazy metals away and take their place. So it has to do with the electrons, which we talked about is the flow of energy in our electrical unit. Some elements have a stronger hold on those electrons than others do, and that causes them or can cause them to be more reactive or less reactive, one versus the other. So a little demo today on what that's going to look like for us. So the chemicals that we have today that we're working with is copper sulfate. Duncan's going to point to the copper sulfate. Okay. We have some water here. Duncan just stand in front of us. We have some tin chloride right here. Point to that one, please, Duncan. We have some, I don't know what that one's called, NaHSO4 right here. And we have pieces of zinc right here.
Right here.
Okay, so the first step we're going to do is we're going to take, we've measured it out, we've got some copper sulfate, and we're going to gently pour it into our first test tube. It's empty. That's why we have gloves on, because it's spilling a little bit. Okay, put it down on the table. And then we're going to take 4 mils of water.
And put it in that?
And put it inside, yeah. There's 4 mils.
That was fun.
That's awesome. Thank you, Duncan. Okay. And we're going to put the lid on. And Duncan's... Thank you. Duncan's going to set the timer and shake that for 1 minute.
I might not. I might do it for a little less because I'm sort of lazy and
Can you stick with the program, please?
Yeah, I am.
Okay, so while Duncan's doing that, I'm going to prepare the second solution, which we have tin chloride, and we're mixing some NaHSO4 into that. The name of that is sodium hydrogen sulfate. Okay, so taking the tin chloride and we're mixing the sodium hydrogen sulfate into it. Which is...
This is hard.
Not happening.
This is so hard.
Why is that not happening?
Timers. And we're back.
So Duncan just completed shaking the solution, the copper solution up for us. So that's done. Thank you, Duncan. Next thing we're working on right now, sorry, a little bit of a hiccup. I had to open up the vial as we're pouring the sodium hydrogen sulfate into the tin chloride. So we're going to do that now. Okay, so that's done, and the red cap is here. Duncan's going to put 20 seconds on the microwave timer for us, and he's going to shake that one up for us. Okay, press go and shake. Shake hard. Okay, for that one.
That shake hard, Dad?
Yeah, I did. Duncan's all in on these chemistry experiments. Thank you, Duncan. I couldn't do this without you. And our camera person as well, too. We really appreciate your help, too, as well on that. So when the timer goes off, we're going to pour that same amount, roughly same amount, thank you, Duncan, into our other test tube as the copper sulfate solution. Just have to get this off. Oh, there we go. That's why we have gloves on. And we're going to pour that in. And it's not pouring. Oh, there we go. I just think there should be a... Looks like roughly the same amount. Maybe just a little touch more. There we go. And we are going to... next thing we're going to do, so the two solutions are ready. Duncan's got his pieces of zinc wire out of the material, and we're going to put them in, one into each vial. And we're going to set the timer for 15 minutes to allow some reactivity to happen here. So we're going to take a small break from you. Dunk's going to put them in.
Wait.
The lids, and we're going to put the lids back on. Thank you, Duncan.
Welcome.
And we're going to take a small 15-minute break, and we'll be back to discuss the results of...
Starting when?
Go ahead now. Come on back in here. So I hope everybody's safe and well and enjoyed their Monday today. This is for next week, but anyways, yeah. Today is Monday. And we'll see you back in 15 minutes with some more results.
Back in a while.
Thanks, guys. So we're back after 5 minutes of letting these vials sit. We thought we'd give you an update on what Duncan is observing 5 minutes into this reaction.
I sort of see fur off a wolf on that one. And then I sort of see black. Just straight black.
What about the describe the solution, Dunk, the liquid part in this one?
I don't know.
Well, what does it look like?
It looks
and
like
the solution over here. What does that one look like?
I don't know.
Okay, is this one clear?
No.
Is this one more clear? Is one clearer than the other?
Yeah.
So one's a little bit cloudy. Can you point to the one that's cloudy? Okay, can you point to the one that's clear? Perfect. So those are more observations that we can look at as part of doing an experiment as well too, right?
Yeah.
Awesome. See you guys in a few minutes. And we're back again. 5 minutes to go. So 10 minutes in. Well, we're going to make some more observations. What do you think, Duncan?
That one has bubbles, and that one sort of has tiny little needles.
Yeah, shards, I was going to call them. What's the color of the solution there?
Gray.
Cloudy or not clear, right? Opaque, I think we call it. This one's bubbling up here. If the camera person can, thank you, camera person, get some bubbles going on there. Still black in color as well. Okay, see you guys in another 5. Thank you. Okay, we're ready.
We're back, and we have finished the task of 15 minutes of this, both this and this.
Okay,
and now we're going to reveal the surprises.
Just follow my lead, okay? Thank you. Okay, so we're back, guys. Just a quick recap again. The first solution has copper 2 sulfate mixed with 4 mils of water, and it's caused a reaction. And the second one we have, I just got to read them, I'm sorry, tin 2 chloride and sodium hydrogen sulfate mixed together, and we have a piece of magnesium in both containers. We let them, magnesium. So sorry, zinc, pieces of zinc. I'm sorry, inside. Thank you. Inside of our test tubes, and we've let them sit for 15 minutes, and we're going to check the results. So
took a picture.
Duncan's going to hold up the zinc.
You open.
No, hold up the zinc to show us what we originally had before we started, and I'm going to just gently pull up the first piece of zinc to show you the end product. Can you pull yours up here? Thank you. And that is what we are left with at the end. Don't touch it though, please. Okay. So that's the first one. And the second comparison is the piece of zinc with the sodium hydrogen sulfate mixed with the tin 2 chloride. Duncan's going to hold his up against mine. And there is the start. Please don't touch them, hon, because we've got to use those for another experiment. Okay, and that is the end product that has been formulated as a result. So my question to you, kids, based on our chemical and physical properties, my big question for you, thank you, Duncan, is did those undergo a chemical change or a physical change? And what's your answer? And why you think it's a chemical change or why you think it's a physical change? Okay. So a few things that we know, just to recap as well too. We know that sodium is very highly reactive. We also know that magnesium is as well too. And copper tends to be a little bit less reactive, but still reactive in the same process. So that will explain some of what happened today in terms of our experiment. So I hope you enjoyed. Please take a second to reflect on your own observations and whether or not you think it's a chemical or a physical change that's happened and why. Okay. Thank you, Duncan, for your help today. Can you say goodbye to the crew?
And goodbye, and please like this video.
Thank you, guys. Have a good day.